Welcome to our presentation. Our topic for today is the Model View Presenter. I'm Alexander Ramirez, and our group consists of me, Omar Perez, Murtuza Barusha, Hassan Ishman, and Josue Rodriguez. We'll be reviewing the history, definition, advantages, disadvantages, purpose, code, and sources for regarding the MVP. MVP dates back to the 90s at Teligent, which was a joint venture of Apple, IBM, and HP. It was a model used to develop C++ based environments. It was later migrated to Java and became popular because of Teligent's CTO Mike Patel. After Teligent ceased to exist, it was picked up by Dolphin Smalltalk for their UI framework. And finally, in 2006, Microsoft began incorporating MVP into their .NET framework. So what is the Model View Presenter? The Model View Presenter is a software pattern that is based off of the Model View Controller pattern because it has many features that are similar. The Model View Presenter is mostly used in user interfaces and has three components, which is the Model View and Presenter.
So the first component of MVP is model. It represents a collection of classes that describe the business logic. It contains the data that is displayed. It can either get the data from a local or remote database or get it from user input from view. It does the necessary operations and calculations and then updates the database. Model has other responsibilities as well, such as calling APIs and caching data. The next component of MVP is view. This is the user interface layer. It's responsible for displaying data to the screen and handling user interactions and notifying the presenter about it. It does not know how the data is processed in the background, and it does not contain any business logic. And the last component of MVP is the presenter. It serves the role of a middleman between view and model. It receives the input from the user using view and passes the data to the model. Then the model processes the data by doing necessary operations and passes the updated data back to the presenter. It has no knowledge of how the actual UI layer works. It just knows how to communicate with it. And the presenter communicates with the UI through an interface.
So how is MVP different from MVC? To be honest, there isn't a lot that is different from MVC, but there are some key differences. In the MVP pattern, the view is more loosely coupled to the model and the presenter is responsible for binding the model to the view. It is easier to unit test because interaction with the view is through an interface. Usually, view presenter map one-to-one. There are some advantages of using MVP pattern, and it is that it simplifies testing. The presenter can be tested without having to worry about the database or the UI. The three different layers of abstraction make it possible to carry out unit testing. Logic implemented in the presenter can be easily retargeted to many different UIs. The model can be switched out as long as it implements the original interfaces, and there's a better separation of concerns. MVP keeps the business logic and persistent logic separated out of activity and fragment classes. This ensures the concerns are separated in a better way. Disadvantages of MVP complexity. When designing a small application or a prototype, implementing MVP will be very complex and require a lot of time. There is tight coupling between the view and the presenter. To convert the UI logic to presenter, the coder has to code and split the code to make sure that each class has only one responsibility.
So the model view presenter design pattern is most commonly used in applications that involve interactive user interfaces. These interactive interfaces are usually event-based, meaning that if you were to press a button, it would take you to the next page or log you into an account or register you an account. It usually performs some kind of action right after. And these libraries and frameworks that we have listed right here, this is where you will see the model view presenter design pattern most commonly used at. So for Java libraries, you can see it in Android Studio, JavaFX, and Swing. You can see it in the .NET environment. If you wanted to use Windows Forms or ASP.NET, you can see it in PHP frameworks such as Laravel and Net. But you will see it the most inside Android. So if you wanted to actually implement a design pattern when designing an Android application, then you would most likely end up using MVP. Overall, you don't need to implement a design pattern for your application, but as your application grows, it could become tedious to maintain or even test current and new functionalities. So, so in terms of Android, if you were going to make an Android application that had a bunch of new features, or you were going to add on new functionalities later in the future and the application became huge, then it would be suitable to actually choose a design pattern, to actually implement a design pattern. It'll only make your life easier. And the most common one, as we said before, is MVP. And the reason for choosing MVP in Android Studio application is because it improves the testability of code and brings heavy separation of concerns. To demonstrate the model view presenter in Android Studio, we'll first list off the 3 components of MVP, with the first one being the view. So with the view, every application will have an activity, and in each activity you could choose to have a fragment as well. It's also considered a sub-activity, and you could also have a custom view. All 3 of these right here is where the user will interact with. And then for the next component will be the presenter, and for each activity you would have one single presenter. For each fragment you will have one single fragment presenter. And then for the next component, we'll list out 2 different models that represent a user and a vehicle. So for the user model, this could have something like the first name, last name, date of birth, email, whatever. And for the vehicle, this could have the car color, car model, car price. And we're going to describe how this whole situation works, where from the start, from beginning, where the user interacts with it and how it goes in flow. So once a user interacts with a view, which is either an activity or fragment or view, it will first notify the activity presenter. And once it notifies the activity presenter, this activity presenter will update or get data from either the user model or vehicle model. So both of these are independent, meaning this is one separate action and this is another separate action. They perform different things. So this is completely independent of this one. So when this first activity notifies the activity presenter, this could be something as updating the user's first name, or update the last name, or the date of birth, just anything in an account it could update. So this could be a database such as Firebase or AWS or Google Cloud Platform. And for this portion with the fragment, it performs the same operation as an activity, where it will notify the fragment presenter. And this fragment presenter, in this case, we're just going to be using it to fetch data. And in this case, we're going to use an API call to fetch data from a vehicle model. And it's going to be a REST API where we're going to be returning JSON. So once after we update or we get data, then this fragment presenter is going to update the view. So in order from how it works is that once the view gets updated from the presenter, this presenter will then display that data to the user.
All right, so now I'm going to be demonstrating our code for a little application we made in Android Studio that demonstrates Model View Presenter. So the first class you see here is the user class. It's the model of Model View Presenter. And typically models are used for handling data, be it from a database online or locally saved, or from APIs. But for our case, we stored our data locally just to make things easier and simpler. The next class we have is our main activity class, and it's the view of Model View Presenter. Its main job is to simply set up the display and the user interface. The next class that we have is the main activity presenter class. It's basically the middleman for our user and main activity class, which are the view and model. And so before I go into details about the code, I'll just start the application now. Unfortunately, the application wasn't emulating on my computer, since my computer has been acting a little strange. So I decided to stream my phone, where I installed the app. And so let's check out this application on my phone with a stream. So once you open the app, you notice that there's the app name on top, and then you have 2 edit text boxes down here. So I'll just input some email, so QWERTY. And if you notice, like, it's being updated as I'm typing. So there you go, gmail.com. And just for functionality's sake, I'll input the second text box as well. So QWERTY is the greatest username ever. So any information that I'm typing into the edit box is being instantly shown to us, and it's being live updated, so to speak. So let's go into our main activity, and so I can explain a little bit more what's going on. So the first thing you see here is the onCreate. So onCreate is basically a method where you get the basic application startup logic. So anything that the application needs to have running the moment it's turned on, it's going to be inside of this bracket, basically, inside of this method. And so everything over here is basically the layout structure, having a toolbar, connecting the layouts. But the thing that we want to focus on here is this stuff right here. So if you notice, they're both the same things happening, except one's for email and one's for username. But what we want to focus on is the text watcher. So text watcher is a interface that is used to watch change made over the input text fields. And for these, you need it requires having 3 callback methods, which is the before text changed, on text changed, and after text changed. But since we don't really care about what happened before or after, we want to focus on what's happening at the time live. I left these 2 methods blank. I focused on the on text changed. So the on text change references to the main activity presenter. So let's go into that. Let's see, here is the function. So it goes for update email. So it takes the information that it receives, converts it into a string so it can send back to our database. So it updates the user info text view, sends it over here. You see set email. So it receives the email that it got from the main activity presenter class, saves it into the email, and then what you see on the application right here, email live update, it's basically showing whatever got saved into email. And that's pretty much it. So as you know, like, I only showed the email part. The name part was also the same. It's just it was a lot easier to explain one since they're the same. It's redundant to explain both of them. And this super simple code is a perfect explanation of MVP. You have 3 different classes working together. You have one class that's a middleman between the 2 classes. One's where the input comes in and output is shown, and one is a class where you get that data into. Meanwhile, the middle class is handling the information back and forth. Now, this entire application could have been made in one class, but it just makes it a lot harder to follow, so to speak. With the MVP, it just simplifies things. Like, for example, if we did this entire application in one class, we would have a hard time differentiating the problems we're getting from one text box and the other one. So just completely separating each task just makes programming way easier and more visible. Like, as a coder, as a programmer, you can see what's happening. And that is it for the demo of the application and explanation of the code. Thanks so much.